Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. We are now at question 2 part A, CSET Math Exam June 2012 video solution. And the first question here, part A, wants us to factorize completely. And the first factorization is 2x cubed y plus 6x squared y squared. Now if you look at the numerals, the highest common factor is 2. So we can show that first. Then if we look at the terms in x, we have x cubed and x squared. And so the highest common factor between these two terms is x squared. And then if you look at the y's, we have y and y squared. The highest common factor of these is y. And so this is our highest common factor from these two terms. And so we carry out the factorization by dividing this term by 2x squared y and dividing this term by 2x squared y. And the result, firstly, is on this side, the result is x, and we divide by 2x squared y. And on this side, when we divide this by 2x squared y, the result is 3y. So this factorization is correct. Let's move down now to part 2. Now in part 2, I see two terms with a minus sign, so I'm thinking it's a difference of two squares. So all I need to do first is check that I have perfect square term here and a perfect square term here. Now 9 is a perfect square of 3 and 4 is a perfect square of 2. So therefore this expression can be expressed as the difference of two squares. So let's go ahead and show that. This term becomes 3x all squared, that's 9x squared, and this 4 becomes 2 squared. And now we can apply the rule for the difference of two squares, and this is it. This becomes 3x minus 2 multiplied by 3x plus 2, and that's it. We have factorized completely the difference of two squares. Let's look now at the third part. Now in this third part, I see 4 terms. So this is telling me that it's a factorization by parts. So what I want to do is find the highest common factor from these first two terms and then find factors of these two second terms such that a common factor exists on both sides. Let's go through the steps. Now firstly, the highest common factor between these two terms is 4x. And when I divide 4x out of this term, the result is x. And when I divide 4x out of this, the result is 2y. But what I want to do to ensure that we have x plus 2y as a factor on this side is put that factor in first. And this is it. And then if I observe, coming from a negative xy, I am having an x inside the bracket here. So it means that we must have factorized a negative y outside here. So let's go ahead and show that. And then all we need to do is check that this factorization is correct. So negative y multiplied by x is negative xy, which is correct. And negative y multiplied by 2y is negative 2y squared. So that also is correct. And what we have now is a common factor, x plus 2y here, x plus 2y here. And then we can go ahead and factorize these two terms using x plus 2y as our common factor. And that's it. The result is 4x minus y multiplied by x plus 2y. That's 4x times this minus y times this. So the result is 4x minus y times this. And that's it. We have factorized completely. Now let's move down to question 2b. Now question 2b is asking us to solve this equation. To solve an equation basically is to find the unknown in the equation, and the unknown is x. So we are solving for x. Now what we want to do first is simplify this equation by getting rid of the fractions. To get rid of the fraction on this side, we would multiply the equation by 3 And to get rid of fraction from here, to get rid of the 2 from here, we'd multiply by 2. So essentially we want to be multiplying by 3 and also by 2. And so the result of multiplying by 3 and then by 2 is actually to multiply by 6. If we multiply this equation by 6, we will get rid of this fraction, this denominator here, and get rid of this denominator here. So let's go and show step by step how we multiply the equation by 6. When we multiply the equation by 6, we have to multiply each term in the equation by 6. So we're multiplying this fraction by 6, we're multiplying this fraction by 6, and we're multiplying this 3 by 6. So that's it. And then all we need to do is simplify each term. So here we can divide numerator and denominator here by 3. Let's show that. When we divide this 3 by 3, the result is 1. Divide this 6 by 3, the result is 2. And then here, when we divide this 2 by 2, the result is 1. And when we divide this 6 by 2, the result is 3. And then 3 multiplied by 6 on this side is going to be 18. So here now, we're going to multiply this 2 by the 2x minus 3, and that's going to give us 4x minus 6. And here, we're going to multiply this 3 by the 5 minus x, and that's going to give us 15 minus 3x. So let's show that result in the next line. So that's it. That's 4x minus 6 from here. 2 multiplied by 2x is 4x. 2 multiplied by negative 3, negative 6. 3 multiplied by 5 is 15. And 3 multiplied by negative x is negative 3x. And then 3 multiplied by 6 here is 18. And so we can simplify now. 4x minus 3x is x. That's the like terms we're adding now. 4x minus 3x, and then 15 minus 6, that's 9. So we end up with x plus 9 on this side equals 18. And if x plus 9 is 18, then x must be 9, because 9 plus 9 is 18. Or simply, we can subtract the 9, this 9 from this side, and we see the result. X is equal to 9. So that's it. X is equal to 9. And that's the answer for question 2b. Let's do now question 2c. In question 2c, we are given a pair of simultaneous equations to solve. That's these two equations. And we observe we have a negative 2y here and a plus 5y here. And we can solve this by elimination. What we will do is adjust the two equations so that we can eliminate y. So if we multiply this first equation by 5, then this becomes minus 10y. And if you multiply this second equation by 2, this becomes plus 10y. And then we'll be able to add the two equations to eliminate y. So let's go through the steps and show that calculation. Well, first, we're going to call the two equations equation 1 and equation 2. And as I said, we're going to multiply equation 1 by 5 so we can create a negative 10y here. So let's show that. That's it. We multiply this first equation by 5. This becomes 15x minus 10y, and then 5 multiplied by 10 is 50. We simply multiply each term in equation 1 by 5. And then, as I said, we're going to multiply this second equation by 2, and then this will become 10y, right? And we have to multiply each term in that second equation by 2. So that's it. We are multiplying the second equation by 2, and when we do that, the result is this becomes 4x, this becomes 10y, and 2 times 13 is 26. So we have now created a situation where we can add these two equations and eliminate y. So let's call this adjusted equation equation 1 prime, and this adjusted second equation, let's call it 2 prime. And now we can go ahead and add those two equations. So adding 1 prime and 2 prime, when we add these two equations, we simply add the terms on this side and add the terms on this side. When we add the terms on this side, we're going to get 15x plus 4x, that's 19x, This negative 10y will eliminate this positive 10y, and then 50 plus 26, that's 76. So let's show that addition. That's a 15x plus 4x, that's 19x. The y terms are eliminated, and then 50 plus 26 is 76. And then from here, all we need to do is divide through by 19, and that will make x the subject. So x is 76 divided by 19, and that is x equals 4. And now we need to find the corresponding y value for x equals 4. And to do that, we substitute in any one of the two equations. But what we can do is substitute in this second equation where there are no negative signs, because we tend to make mistakes with the negative. So let's reduce the chance of making an error by substituting in equation 2. So that's it. We're going to substitute x equals 4 into equation 2. And to substitute x equals 4 in equation 2, we are simply replacing this x with 4. And that will give us the opportunity to calculate the value of y. And this is it. We are substituting x equals 4 in this second equation. It becomes 2 times 4, that's 2x becomes 2 times 4, plus 5y comes back here, and then the 13 comes back here. And all we need to do now is solve this equation for y. So that reduces to 2 4s 8. 8 plus 5y equals 13. And we know that 8 plus 5 is 13, and therefore y must be 1. Right? 8 plus 5 is 13, and so this y must be 1. Or simply, we can say we subtract 8, and 13 minus 8 is 5, and then divide by 5. So 5 divided by 5 is 1. Right? In any case, the result is y equals 1. So that's it. X equals 4, y equals 1. And so we can write our solution line. Solution is x equals 4, y equals 1. And that's the answer for part C of question 2. And that's the end of question 2, and we will do question 3 in our next video. Okay, see you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 CAPE Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.